people. Hi. So, how are you guys doing with the Frontmania 2023? Are we having a good time? Yeah. Perfect. This is, by the way, the perfect amount of people here. I love it. No, it's perfect. It's way perfect. Even though it's so perfect that you can ask questions in between. I'm fine with that. If anybody has a question in between one of those slides, let's see if this works. Yeah. Then you can just ask them. So I'm going to talk about why this current generation of AI is actually like a framework for AI scientists. And what the generative AI and what it means that it's actually an anything-to-anything translation device. First, I'm going to tell a little bit about myself. My name is Vince. I don't have a last name. I'm from the campus consultancy at I/O. I'm a front-end developer. There's my email. I see everybody taking pictures. Amazing. But like for a little note, the technical landscape of this current version of AI is way more intricate than this presentation. This is just the tip of the iceberg. Okay, so let's start off with the age-old question that, everybody probably heard. Like, what is AI? And I have two distinctions within AI. Only I say this. It's not in the field that they call it classical AI, maybe traditional AI sometimes, but I call it classical AI, and now we're dealing with the transformer model AI. I'm wondering, how many people here are using ChatGPT on the daily? Oh, that's way more than I expected, to be honest, because the last presentation I gave. Yeah, exactly. Yeah, great. That's amazing. Me too, by the way. You can see in the slides. Who uses it to do like half of their work? Yeah, perfect lazy people. I love it. Okay, so I'm going to talk about classical AI first. So what is classical AI? We've probably all seen pictures like this, right? It is, they see like this a car. This is computer vision, car, person with an umbrella. And this is a bus, but they call it a truck anyway. This is a car. Or you've seen classical AI that predicts like the median between all these points, and then it tries to predict the next point where it might be. We've all heard about this. So what is classical AI good for? There's a lot of things. If you've ever seen TensorFlow, if you ever used TensorFlow, then this might be a very familiar picture. But classical AI is good for like numerical data, big data, forecasting, classification, email filters, content algorithms, like on Facebook or Instagram or Reddit. They all have like a sort of AI to make your feed personalized. And this AI has been here for a long time. And with classical AI, they also try to do all these things, right? So like computer vision, voice recognition, natural language, all these things, they tried to do this. And they succeeded, most of them. But the problem was with this, with trying to solve these problems with classical AI, is that they are completely separate from each other. If one, for example, natural language processing, if they have made some improvements, like 1 or 2% improvement in their fields, then all the other fields has nothing to do with it. They're so completely different, like completely different buildings, just for say, and in their code base. They started off maybe only with TensorFlow to do some AI calculations or machine learning calculations, but the rest is completely different. Even in their papers, nobody understands each other. It's completely different jargon even. So what if you wanted to do an image generation, but with your own voice, that you could say, like, I want to have a picture of a hedgehog that is blue with their eyes together, and it goes very fast, right? The Sonic the Hedgehog, okay. So they do voice recognition. That's a completely separate building. just to transform it into text. And then you have to bring it to the natural language processing building, who has a completely different set of requirements to accomplish their goal. And then you have to go to the image generation building, who will also have a completely different mindset about how AI should work. So in 2017, a new AI has been invented. And it was originally invented for Google Translate. And it all started with a white paper called Attention is All You Need. And I'm going to tell you, what is attention? Well, it is here, hi, but that's not the attention that I mean. The self-attention is actually a natural language processor with a magnifying glass. Meaning that if you give this AI a large piece of text, then it knows exactly what are the most important stuff that I need to put a magnifying glass to. So if it has a lot of, if it comes over a lot of times in the training data, a certain word, for example, that it knows that that word is important. So if you know Dutch, for the people who can speak Dutch, this is Google Translate. We have some proverbs that are pretty weird in Dutch language, like klaar is Kees is not done is Kees, but it's just done. Or helaas pindakaas would actually be translated to unfortunately peanut butter, but because of the community, they know that it is actually too bad. So the community has given it so many times, has told so many times to Google Translate that it means too bad, that it became, the AI put a magnifying glass on the helaas pindakaas so that they know that that is an important word that is coming a lot in the community dictionary. So what it basically does, it transforms one language into another language. This AI transforms one language to another language. And then with the self-attention model, it knows that this actually means something else instead of, unfortunately, peanut butter. So a transformer. The AI from Google Translate is a natural language processor. We all understand that because it translates natural language. And it is trained by the community. Well, what if we have a pre-trained transformer? Somebody thought of the idea, like, instead of community words, let's just train it by all the text of the internet. Let's see what will happen. Somebody was curious in order to do that. Let's just, instead of giving the community little bits of pieces of text, let's just put all the text of the internet in there, and let's see what comes out. And then what is generative pre-trained transformer? Is when you reverse the training data into chunks of outputs. Can you already see what this is? GPT, right? So it's when they make generative, is when they reverse the training into chunks of output. What do I mean with chunks of output? When you start ChatGPT, you can see that, let's just do tests. If it works, demo. It worked 5 minutes ago.
You do have a last name, iPhone.
Okay, let's try it out. Okay. As you can see, it appeared. You can see that it appears slightly word for word. But that is a technical limitation from GPT, because they decided to translate this into this. And then you have this part, and then they do it again. This into this, and then this into this. So it's like one function call every time they output one token. That's why you see that in the ChatGPT that it appears slowly. Well, this is an easy question for you guys. This is like example training data. This is like super simple example training data. And you have horizon that has expands 4 times that behind it, and then meets, line, and shifts. And what if you input horizon? What would be the output? Expands, exactly, because that's a 50% chance that it would put out the word expand. However, GPT-1, the first version of this whole experiment, wasn't that smart. So, for example, when you asked, what is 7 plus 8? It says 7 plus 8 equals 10. Well, that's obviously wrong. And they say, no, that is wrong. It's 15. What is 7 plus 8? And then it says 7 plus 8 is wrong. It's 15. And then it says, okay, but what's 2 plus 2? And then it says 2 plus 2 equals 15. But it does the math wrong. But it does understand that something is wrong. And that is this. So it could already do a little bit of reasoning. Not real human reasoning, but it can do calculations so well that it can do language. Yeah. So later, when they found out that GPT-1 can do language and reasoning, they also found out that everything is actually connected with each other. So what we had before is when classical AI only has like natural language processing as a single building or a single field in AI. Now natural language processing is in the middle of all the AI. And you could translate or transform natural language into anything, like images, sounds, voice, code, music, video, and brainwaves maybe even. And you can also like translate music to code, for example. Why would you do that? I don't know, maybe you want to listen to your code if it has any bugs. So natural language is actually everywhere, if you think about it, right? Voices has been transcribed, images has been described, music has been described, speech that aligns with the video. So for videos, physics has been documented in words, code has comments, hopefully. So how can we understand anything without natural language? Everything has natural language. So that is why the transformer model is like a framework for AI. The frame it works within is natural language. That's why we have this enormous explosion nowadays of new AI, because they found out that natural language can do a lot more than the classical AI. So you can decide what it generates, music, images, code, by providing the right training data if you have the pre-trained transformer at its base. Whoever seen this picture? Anybody ever seen this picture? Yeah, so this is chatdev. These are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 AIs that are working together to make software as cheap as possible in the least amount of time. I think they made 7 pieces of software within 1 minute, within 10 minutes, within $1. And it's going to be the future of software development. So what happens is then first they're going to design the requirements, then they do coding, testing, if it all works, and then they document it, and the documentation is important for the designing again. This is how they do waterfall programming.
But didn't they achieve that they made 80% of the software, something like that?
Yeah. Yeah, they made a lot of software, but you still need a human intervention in order to check everything again. Is anybody really playing on the playground? Okay, let me show you something about temperature. Everybody, who uses the OpenAI API in their own projects? Okay, good. Do you know what a temperature means? It's often like a mystery to most people. So I'm gonna say my grandma's infamous recipe for, and can we guess what might be the next word? Apple pie? Somebody say apple pie? Let's see. Probably apple pie. Oh, deviled eggs. Okay. But you can see that there's some red and some green and some yellow in there. So what does it mean when it's red? It means that it actually wanted to do chocolate and then apple, so chocolate cake was probably the next word, but it chose dev for deviled eggs. And why did it choose dev? Because the temperature is at 1, meaning that it chooses something more random inside of it. And then these are all less random, because if you go to a green one, it is the most likely word. So what do you think what will happen if I put this at 33? Oh, yeah. You can see that these are almost all green, and even this is the most likely word that they chose. And what would happen if I put this all the way up to 66? Yeah, that doesn't make any sense. Like, it does kind of make sense, but it doesn't make sense here anymore. But it does know that it has to be something with ingredients. So with this recipe word, it knew that it's going to be ingredients here. And you can see about, let's say, the 33% or something is logical, and the rest doesn't make any sense anymore. You probably wondered, okay, brainwaves, how can you translate something into brainwaves? Has anybody heard of this article before? Yeah, well, actually one person. So, okay, how to read mind like a totally normal scientist. Okay, we're gonna, first of all, select a human subject, and then put an fMRI device, so you've seen it in the last slide, and then let them read out a sentence, like 40 or 50 times. They are going to read out a sentence that they have in front of them. And then record the voice and the brain scans, and then the actual hard stuff. And then train the transformer model with the brain scans, voice recorders, and spoken text. Right? So you train the transformer model with the 3 things that you have recorded. And then you reverse the training data to generate output instead. And then only use the brain scans and inputs, and then the AI generates the texts. So what happened, this is the actual result of the brain reading device. You can see there's exact, gist, or an error. And you can see that when the the human subject, read this out, or no, not even read it out, but just thought about these words, the words window and glass was understood by the brain reading device. This is maybe a little bit scary. I was wondering if I should really put this in. But here you can see like scream, cry, scream, then cry, or lay down on the floor. That was all read successfully. And you can also see like this is the actual hard part of the brain reading device, but it all uses the transformer model as its framework. Who wants to code with ChatGPT as a tool? Who really wants some rule of thumbs? So if you want to code with ChatGPT, you have to split it into small tasks. Never mention your end goal, because that kind of messes up the context. You don't need big prompts. I'm not a fan of big prompts. I'm a fan of really small prompts with the right amount of context. And you have to remember that it always transforms one piece to another piece. Let me show you an example by making a heart in SVG in ChatGPT. Okay, so SVG reader. Okay. Make a heart in SVG. Oh, it worked. Not supposed to work. Okay, let's let's do this again. That's the best one I've ever seen. Yeah. Okay, this one sucks. Okay, good. So this is what it thinks, and it even made an explanation about all the steps that it made. But let's do the steps ourselves. Okay. So instead of make a heart in SVG, make a 100 times 100 SVG. Oh. Print it out for JS. No, for HTML. Okay, now we have 100 by 100. Okay, remove the contents and just do this for now. Okay, start from the middle bottom with and make a line to the 25% height to the right wall. Let's hope it understands this. Okay, almost. This has to be 25. Okay, so y2 is 25. Then make a circle in the second quarter. Now copy that. Now mirror that to the other side. And this is how I also approach all my projects that I'm working on. Personal projects, not projects with your job, because those have some ethical thingies with it.
Imperative programming.
Yeah, kind of. There's, well, this is my attempt to a heart. Thank you. Okay. And another thing, but that is on a different.
Is that a form of extreme programming?
No, wait. It's not a form of extreme programming. this the one?
You asked it to make a heart, then you're doing declarative programming.
I would say, well, it's not declarative programming. It's more this in this example with the heart. I'm just showing what it looks like to do it step for step. If the AI cannot do it in one time, because if you try to tell the AI, yeah, I want to make a whole app, you cannot just say the whole app. You have to restart from the beginning and make it into small little steps. Okay, so imagine that you're an accountant. Customer, Mr. Human, wants to buy 40 pairs of socks. They agree to pay half up front, so first all the left socks, and then pays the other half when the socks have arrived. The customer wants 2 separate invoices for each payment. With the shipment code, you can automatically send the second invoice. Well, that is all in in an accountant software, like Exact or something like that. It is all possible. But in order for an accountant to accomplish this, they have to do all these steps. They have to do all these steps in order to accomplish that. That takes a really long time. So who heard of AI function calling? Now, function calling is seriously the best thing that OpenAI API has to offer right now. So you can just declare a function like search customer and then search for a customer in the system based on the criteria. And then this is a JSON schema. You can just put in, and then some other parameters. And then you put a chat box in your program. Like Mr. Human just ordered 40 pairs of socks and wants to pay half now and the other half when it arrives. He wants 2 separate invoices. And then you say, okay, let's find Mr. Human in the database. And then it calls the search customer function. Here I have the information for Mr. Human. Let me find a product ID. And then it calls search project function. Here's the ID of the socks. Let me fill in the invoice form for you, etc. Well, I have a little example here. This is my app that I'm currently making. This is a weightlifting plan and tracking app. And you can see here I have made a JSON schema of the function for create a workout. So if let's just reset this just to be sure. Demo. Okay. Tell me about my workouts. And this is just a sort of console log in the chat. This is what the AI is now receiving. Now it is thinking. Yeah, and it says, yeah, this is all your workouts that you have. Let me know any specifics, and then I say, what would you recommend for a 5th workout? What does it say? Yeah. Create a back workout for me. And then it function calls this create workouts that I have here. So I can approve, I can cancel, or I can edit, and it will immediately fill in my form and does it automatically. And if I submit it, then here's my back workout that it made for me. Well, it's not that full yet, but it works. Could also, like, for example, create an exercise or all the other things. How much time do I still have? Who wants to see me do something else? Yeah. Okay. Great. Who here has ChatGPT Plus? Who here ever used advanced data analysis? Yeah. Let me just for fun, let me create a trading bot. Okay. What are some functions for technical analysis for a trading bot? Be brief, please. Okay, it gives me some examples of some trading bot technical analysis. Okay, I was hoping that it would be keep it simple. Please give me the calculations for MA. And then it will make all the calculations for it. Now transform the calculations in Python in the environment. Now it will create it in Python. Okay, and then I upload the AAPL, which is from Apple. These in here are all the closing numbers. Let's see. Backtest these functions as a trading bot starting with 10K. Okay, first it's going to read whatever is in the CSV file, and then it notices, okay, so it has date open, high, low, close, and it acknowledges that. It now also knows that it is Apple stock. Now it's going to implement the backtesting. And it fails. Okay, for some reason it says final portfolio value approximately. That's unique. Okay. Well, it says approximately 800. What? 1.8 million? No, that doesn't work. No, that is not true. Did I say 2015? Does anybody remember if I also added 2015? No, okay, I forgot that. Let's go back. Trading bot backtests 2015. Stop. Let's do it again. I'm really holding my breath there. It's an internal server error. Okay, let's just take a deep breath. In 2015. I want you to create a trading bot that is optimized for 2015 using MA technical analysis. Okay, now it's going to filter 2015. Yeah, this is just a warning. You can always ignore that. Okay, starts with 100K. Calculate profit is 0. Did something wrong. Why does it always work when I'm not on stage? Okay. Can you fine-tune the parameters? Okay, so now it's gonna try all the parameters within 1061, 100, and 251. So this is gonna take a while because it's a for in a for loop. Gonna calculate the best. I'm gonna hold my breath again. See if it works. Last year I was talking here too. I was talking about how we could generate text for a blog and with a generated image with it fully automatically. So when a certain a customer came onto the blog, it would analyze that customer for which blog post they are interested in and then generate new blog posts that are specified for their niche interests. But last year, nobody knew about AI yet. Nice. 000. I wish that this would be better.
Zero is a profit.
Yeah, well, yeah, you don't make any loss as well. That's a good thing. How about Bollinger Bands? Okay, good. I made a loss, but at least it is something. Can you now fine tune it?
Did you use this to make a profit?
Yeah, so what I did in my own projects is I used this and then the fine-tuning parameters because Bollinger Bands wants a top, a middle, and a bottom in order to know when the buying and selling signals are. And in my own project, I would fine-tune the 3 parameters of this technical analysis, and then I would say, what do they have in common? What is the major trend in those fine-tuning parameters over the year? And then I try to calculate and predict the fine-tuning parameters for 2024, so I would know when it would work. Well, guys, I think I'm going to stop it right here because I'm going to fill even more. I don't want to have that. Guys, thank you very much for coming to my talk. I hope that you've learned at least one thing. One person. Yeah, I can see all the bulbs lighting up at everybody. Thank you very much, and I hope you have a great time here.